Howdy and good day, fellers. In algebra, we'll be going over PO21, our kind of introduction to that whole concept of slope, change in y over change in x. And then we'll go into PO22, where we're actually going to find slope when our relation is a graph, or if we're just given two ordered pairs of a relation. So here we were kind of looking at function tables and determining if they have that constant change in y over change in x to see if they are linear. Today we'll be working with specifically linear functions and learning how to find the slope of the line. First, some administrative items, however. Khan Academy is due tonight. You have literally the entire day to do it, not until 11:59 p.m., but don't forget about that. Also, I sent an email home to your parents yesterday. With me being out, the process for retaking objectives has slightly changed. I've posted all of the practice work on Google Classroom, and so if you'd like to retake something, and you have until the end of the try to do it, December 3rd, go in, print the practice work, complete it, and then email me a picture of your work. Okay, and when you go in there to print this practice work, do not open it as a Google Doc. You know how technology and me, we don't get along. Google and I have a long-standing feud. If you open my practice work in Google Docs, it messes with the format. It moves things around. Fractions don't show up correctly. It's just a mess. So print it out as a PDF or download it as a PDF and go about it that way. Do not get into Google Docs. But then once you email me the practice work, a picture of it, when I approve it, I will send you the retake, and then you can send me a picture of that once you take it, and that will improve your grade. So if you're in geometry, make sure you grab packet number 4 from my desk. I still see there's quite a large stack there, so if you forgot yesterday, grab that today. Geometry folks, there's also a lesson I recorded for you. It is uploaded on the Google Classroom page. With me not being here, I don't want to get too far behind in geometry. So you 8th graders that are in that, check that out. It's due by the end of the weekend. You'll have one tomorrow as well. So PO17 and CO18 due by the end of the weekend. And my 7th grade homeroom, I walked by my penny bag today out in front of the office, and goodness gracious, it is empty. What's going on? Let's go, okay? Bring in your pennies, bring in your silver, put them in other people's bags. Pennies go in ours. Let's see if we can't come away with a respectable total here for the penny wars. But anyway, I digress. I think that's it. If I think of something else, I'll certainly say it. Football picks are due today as well, so don't forget about those. Standings are coming. Okay. So your job was to look at the change in y over change in x and determine whether or not this relation presents a linear function. So going down the y column here, we're plus 2 from 2 to 4. 4 to 8 is plus 4. And 8 to 16 is plus 8. Like we saw yesterday, don't give up yet here, right? We'll see what happens. Because really it comes down to when we go across the table, if we have equivalent fractions, right? Equivalent rates of change in y over change in x. But in the x column, 7 to 11 is plus 4. 11 to 15 is plus 4. And 15 to 19 is plus 4. So when I look across now, I've got change in y of 2, change in x of 4, and then 4 over 4 for the second one, and then 8 over 4 for the third one. Those are not equivalent fractions. Those are not equivalent rates. So this does not present a linear function. Even though there's some sort of pattern going on here with that y column, it's not a linear function. And who taught me how to circle numbers? How did I miss 19 and 16? Oh, goodness gracious. Okay. Second row, first one. Going down the y column here, we've got 25 plus, or to get from 25 to 50 is plus 25. Then we stay at 50, so plus 0. And then we subtract 25 to get down to 25 again. This is not looking promising whatsoever. The x column here, we have plus 100. And then 200 to 300 is another plus 100. and then 300, 400 plus 100. But I can just, this is not going to be good. Oh, that was even worse. What's wrong with, oh, I guess I am circling in the middle, aren't I? Okay, I don't feel quite so bad now. As long as I get the green numbers, that's what really matters. 25 over 100, 0 over 100, and negative 25 over 100. No, not equivalent rates, no linear function there. Okay, might still be a function, right? It is not going to be a line. Maybe the graph of this looks something like this or something. I don't know. Still a function, right? The vertical line test, there's no point on that graph that'll cross it twice. No x value repeats itself, but it's just not a linear function. It's not a line. The two graphs we already talked about. Is this a line? Yes, it is. Therefore, it is a linear function. Is this a line? No, it's not. Therefore, it's not a linear function. That was fun. The last one here, y column. Ooh, this is tough math here. 50 minus 21 to get to 29. Then 29 minus 21. Ooh, okay. Gets us to 8. And then 8 minus 21 gets us to negative 13. This one's got potential. But we have to look at the x column too. 9 plus 7 is 16. 16 plus 7 is 23. And 23 plus 7 is 30. All right. So I can just, read across. I don't have to circle anything here. All three of these have a change of y of negative 21 and a change in x of positive 7, which we could simplify this down to be negative 3 if we wanted to. Okay, but that is a linear function, folks. The constant, or the change in y over change in x is consistent. It is constant. It's the same. And we have ourselves a straight line if we were to graph that. Your answers on the bottom two obviously vary. So for this one, we kind of did this one together in class a little bit. Basically, one column should be either increasing or decreasing by the y column should be increasing or decreasing by 2, and then the x column should be increasing or decreasing by 7, but one's got to be going up, the other one's got to be going down. If both are increasing, y is increasing by 2 and x is increasing by 7, then you have it wrong. If y is decreasing by 2 and x is decreasing by 7, you also have it wrong. Okay? Doesn't matter which one's going up and which one's going down, but one of those is increasing, the other one is decreasing. For 5 over 4, basically, your y column, each value's got to be going up by 5, so maybe you just have something simple like 5, 10, 15, 20. Your x column has got to be going up by 4, 4, 8, 12, 16. Change in y is 5, change in x is 4, we get positive 5/4. You could also, and this is a little bit sneaky, you could also have y decreasing by 5 and x decreasing by 5, right? If we wrote this the other way, if we started at 20 and went down by 5s and started at 16 and went down by 4s, now we have a y change of negative 5 and an x change of negative 4. But what's negative 5 divided by negative 4? What happens when you have a negative divided by a negative? You get a positive. So you could either have both of them increasing, y by 5, x by 4, or both of them decreasing, y by 5, x by 4, and you've got yourself a linear function. I was going to say something else about this too. I don't remember what it was though. So make sure that, the biggest mistakes that folks make here is they forget which variable is the numerator and which is the denominator. Okay, that's why we have kind of the rise over run phrase that I brought up. Rise over run is kind of a shortcut phrase that people use. One thing you could, rise, wise, kind of rhymes, so rise up on top, wise up on top. You rise up, right? You run sideways. So the rise refers to the y-axis going up. The run refers to the x-axis going to the side. Or rise over run, and then you're done, because it rhymes. Or rise over run, let's have some fun. That works too, okay? But just make sure that your y variable is the numerator, your x variable is the denominator. Okay, let's go on to the quiz. Let's talk about the quiz, which went very, very well, much better than PO20 did. Not terribly surprising. PO20 was kind of a difficult one, and not that this one was easy, but this was much, much better. So the first one, and relation? Who wrote this garbage? My gosh, what an embarrassment. My editor is fired immediately. A relation is a linear function if the change in y over change in x is constant. That is the definition of a linear function. Yes, the change in y over change in x is constant. So that would be true. That would be true. Number two. Does the relation below represent a linear function? We're looking for the change in y over change in x. Looks like we're going plus 5 to get from 2 to 7, plus 3 from 7 to 10, and plus 3 again from 10 to 13. We're not done yet. Let's not jump to conclusions. 8 to 11 is plus 3. 11 to 15 is plus 4. 15 to 19 is plus 4. Well, okay, let's take a look here. If we go across, we have 5 over 3. Oh, but that's not the same as 3 over 4 and 3 over 4. So 2 of them are constant, but that first one isn't. So no, this would not be a linear function. Okay. Next one. Does the relation below represent a linear function? Going up on the y column here. Sorry, we're not going up the y column, but our values are. Going up by 1, 5 plus 1 is 6, 6 plus 1 is 7, 7 plus 1 is 8. On the x here, -1 minus 3 is -4, -4 minus 3 is -7, -7 minus 3 is -10. This looks pretty consistent to me, looks pretty constant. So the rise over run for all of these is 1 over -3. They're all the same. So yes, sir. That is a linear function. Okay. And number 4, what is the change in y over change in x and the relation below? Let's see if I can get all the answers on here. I guess I can if you go like that. Okay. So looking at the change in y, 19 minus 5 is 14. 14 minus 5 is 9. 9 minus 5 is 4. 6 plus 7 is 13. 13 plus 7 is 20. And 20 plus 7 is 27. So in all of these, the change in y is -5. The change in x is +7. That's consistent for all of them. So it's not 7 over 5. It's not 5 over 7 because that 5 is negative, so it is going down. This would be it's going up 5 and up 7, so that's out. It's not 7 over -5, which you would have gotten if you put the x variable on top. So that was probably the most common wrong answer here, because the most common mistake that's made is putting the x variable as the numerator of this slope rather than the y. So since y goes on top, it is -5 over 7. And the change in y over change in x is constant. That's why this one is not an answer. And so it is the 4th option there. Okay. All right. Excellent. Excellent. Let's go to PO22, where we dive into slope a little bit more. PO22. I can find the slope of a linear function by interpreting a graph or using a formula. So here's my little nifty tidbit here. Hello. In CO21, we learned that slope and linear functions are connected. A linear function will have slope, and if a function has slope, it's a linear function. So kind of the geometry people here, this would be an example of a biconditional statement. If it's a linear function, then it has slope. The converse is also true. If it has slope, then it is a linear function. If you know one, you can conclude the other. Okay, it works both ways here. So slope, I had a definition in my head before I started recording. I was like, oh, that's a perfect way to explain it. But I think, okay, it is a rate comparing the vertical change of a line to the horizontal change. A rate comparing the vertical change of a line to the horizontal change of that line. I'll say it again. It's a rate comparing the vertical change of a line to the horizontal change of the line. And rates are written as fractions, so you'll see slope oftentimes written as a fraction. A common phrase you'll hear with it is rise over run. But I forgot about it. Essentially, it describes how a line moves across the coordinate plane. Mental note, make 3 lines for the definition. Describes how a line moves across the coordinate plane. Is it going up and over? Is it going down and over? Slope will tell you that. Essentially, it's describing how the line moves across the y-axis, that vertical change, compared to how it moves along the x-axis, that horizontal change. So let me show you what I mean here. Given a graph, it's easier to see slope when you've got the line graphed. But how does this line move across the coordinate plane? How do I get from the point -2, -1 to the point 1, 1? Okay, and we're going to think about this in kind of like boxy. You don't just say, well, you follow the line diagonal up to the next point. No, we're looking at, if we can only travel along these grid lines here, where do we go? We're going up to a vertical change of 2 and right 3, a horizontal change of 3. From one point to get to the next, and you always read a graph from left to right, by the way, just like you read a book. Don't go from the point on the right to the point on the left. Go left to right. And the vertical change comes first. Up 2 over 3. The slope of this line is 2/3. Okay? Up 2 over 3. And this is constant, right? If we go from 1, 1 and we go up 2 over 3 again, oh look, we're back on the line again. If down here we start at this point, which isn't marked, but we can see it's on the line, we can make it up 2 over 3. Again, counting these squares, counting these grid squares here, we're back on the line again. So your staircases at home are a fantastic example of slope in action. You've all climbed that staircase before where it's like the stairs are different sizes. Isn't that annoying? Right? You're trying to, one stair is really long, the next one's really, really short or something, it's like, no, have the slope be constant. I don't want to have to think about my strides when I'm just climbing stairs carrying 20 target bags. So I only want to make one trip from the car. The next one here. From the point on the left, so we're going to start with this one. How do we get to the point on the right? Okay. Well, this time our vertical change is going down. So we're going to represent that with a -2. Right? Not just 2, that would be going up 2, +2. We're going down the y-axis, and remember that vertical change comes first, down the y-axis, and we're going to the right or over 4. to get from one point to the next. So our slope, our rate of change here, is -2 over 4. Now I said this is a rate, and rates are written like fractions. We know that we can simplify this fraction to be what? As if you're going to respond, empty classroom here, sorry, just force a habit. -1 over 2, right? -2/4 equals -1 over 2. Well, look what happens here. If we start at this beginning point, and instead of going down 2 over 4, like we did, we go down 1 over 2. Down 1 over 2. We're back on the line again. Down 1 over 2. We're back on the line again. Isn't that nifty? So going down 1 over 2 twice is the same thing as going down 2 and over 4 once, like we see there. Another fraction that is equivalent to 2/4 or -2/4 is -3/6. I'm just going to pick a point. I'm going to start here. I'm going to go, well, that was kind of dumb because black on black there, but blue, okay. Down 3 over 6, back on the line again. So not only is -2/4 the slope that we found, any equivalent fraction to that, -1/2, -3/6, -5/10, whatever it is, it will get us from one point on the line to the other. So when you're given a graph to find slope, you just look at it. How do I get from the point on the left to the point on the right? Up and over, down and over, just take that vertical change first. If you're going up the y-axis, it'll be positive. If you're going down the y-axis, it'll be negative. If, however, you are given simply two ordered pairs, we have the slope formula to help us, okay? And the slope formula, so if you're given two ordered pairs, like you are here, I'll just give general ordered pairs, xy and xy. Okay. When you actually do it, there'll be numbers plugged in, like you have, in all three of these things here. But two ordered pairs, ordered pair xy and ordered pair xy. Because it can be confusing, like if I tell you, what's the value for x there? Well, there are two x's, right? And they could very well be different. So we label them with numbers, like an order. This is our first x. That's a bad looking 1. Let me try to find it again there. Our first x, our first y, and our second x, and our second y. Now, those are not like coefficients. We aren't multiplying x by 1 or multiplying y by 2. They're certainly not exponents. They are written smaller, but they're lowered. They're not raised. Numbers that are written below the number like that, it's like an order, first and second. If we had a third ordered pair, it'd be x3 and y3, right? Just to distinguish these. In the slope formula, to find that vertical change, we're going to be taking y2 minus y1 over x2 minus x1. Because, and I'll stop talking so you can write that down. y2 minus y1 over x2 minus x1. Because remember, that numerator of slope is that vertical change. The word change kind of associated with subtraction, right? So we're looking for the difference in the y values and the difference in the x values. This is going to give you the slope of a line when you have two ordered pairs. Your second y minus your first y, your second x minus your first x. So especially if you're, there goes the eraser again. I tell you, I cannot go a lesson without dropping something up here. Especially if you're learning it for the first time, 7th graders and maybe some 8th graders that are a little bit fuzzy on it from last year. I highly recommend that you take these ordered pairs, I'll rewrite them so they're bigger, 3, 7, and 5, 10, and label them x1, y1, x2, y2. First x, first y, second x, second y. Okay? Because if you got them labeled, well, then it's just looking at the formula and plugging the values in, right? y2 minus y1. So my y2 value is 10. My y1 value is 7. Right? y2 minus y1, 10 minus 7. And then for my x2, that's 5 minus x1, which is 3. Okay? y2 minus y1, 10 minus 7. x2 minus x1, 5 minus 3. And that gives me 10 minus 7 is 3. 5 minus 3 is 2. This would be a slope of 3 over 2. So on the coordinate plane, this line increases from point to point by going up the y-axis 3 and over on the x-axis 2. Positive 3 over positive 2. Things do get a little bit trickier when you've got negative signs, but that's why we had that earlier lesson, PO3, on how to add and subtract negative numbers. Label them x1, y1, x2, y2. And the important thing to remember is that this subtraction sign and this subtraction sign are part of the formula. So they have to be in the formula when you write it. The fact that our y2 is a negative 8, well, it's going to be negative 8 in the formula. And then we're subtracting y1, which is 4. So both the negative sign from the value, negative 8, and the subtraction sign from the formula have to be in there. And then x2 minus x1, x2 is 10. The subtraction sign's got to be there because that's in the formula. And our x1 value is a negative 6. So again, we have to write both signs there. The subtraction from the formula and the negative from the value. And of course, what we learned back in PO3 was that when you subtract a negative number, it's actually going to be addition. So this is going to give us negative 8 minus 4 is a negative 12. 10 minus negative 6, which is the same thing as 10 plus 6, kind of write that below down here, that's going to give us positive 16. So negative 12 over 16. How this line moves across the coordinate plane is going down 12 on the y-axis, right 16, positive 16 on the x-axis. Since this is a fraction, we should simplify. Negative 3 over 4 is the slope. Kind of absorb that there. Okay. Third one, lots of negatives going on here, okay? But we're not scared of those. x1, y1, x2, y2. We label them first x, first y, second x, second y. y2 minus y1. Yes, the subtraction sign from the formula and the sign on that value have to go in there. Negative 5 minus negative 6. And then x2 minus x1. Same situation. The subtraction sign from the formula and the negative sign from the 11. So negative 5 minus negative 6, which is really the same thing as negative 5 plus 6, gives us positive 1. 14 minus negative 11, which is the same thing as 14 plus 11, is 25. And so our slope is 1 over 25. Okay? And knowing the slope of a line can help, kind of understand what's going on here. A slope of 3 over 2, I'm just going to kind of sketch it here in this box. Okay? Slope of 3 over 2 means from one point to the next, we're going up 3, just estimating here, and over 2. It's a fairly steep line, right? A slope like 1/25th, we'll make a rectangle here because what's happening here? To get from one point to the next, we're going up 1 and over 25. That's a long ways away. That's like a, ramp type of slope there. If I'm building a water slide and I bring, a slope of 1/25 to the architects, I'm going to get fired. Okay, that'd be a horrible water slide. That's more like a lazy river type of thing. Whereas a slope of 3/2, whee, that'd be kind of fun. Okay, so that's the value of slope there. Let's see what the second page has in store for us. Find the slope of the line that passes through the ordered pairs. You've got two graphs there. The first one, I always get questions here. There's no ordered pairs marked. That's okay. You can make your own. Look where the graph crosses through a corner. There's an ordered pair. It crosses through another corner down here. There's an ordered pair, right? You could use either of those. You can make one here, crosses through a corner. There, crosses through a corner. So find the slope, again, going from left to right here. Here we've got one ordered pair given. I'm looking for another corner this graph passes through. It looks like the only one that it really hits solidly is the origin here, 0, 0. So those two ordered pairs are what you could use to look at that graph and look for the rise over the run, the change in y over the change in x. And then you've got 6 ordered pairs to do here. The dots followed us. 6 ordered pairs to do here. I'm going to put 4 of these on the quiz for today, just to kind of gauge whether or not we're feeling good about this or if we have to go over it again tomorrow. So your homework is going to be to do the work on this page, but then go to Google Classroom, look at that quiz, and then answer 4 of them. The ones down here, it says write 2 ordered pairs with a slope of 2/3. All this means is that the difference of your y values has to be 2. So if you're making 2 ordered pairs and the numerator of your slope is a 2, that means that the difference from y2 to y1 is positive 2. 10 minus 8 gives me positive 2. I could have written... second example here, 5 and 3 is my y's, right? 5 minus 3 is positive 2. That works, okay? And then your denominator, your change in x is positive 3. Well, 9 and 6 make positive 3. 18 and 15 make positive 3, right? You're giving me the original order pairs that would result in a slope of 2/3. If I gave you these ordered pairs, 10 minus 8, there's 2. 9 minus 6, there's 3. There's your slope. 5 minus 3 is 2. 18 minus 15 is 3. There's your slope there too. Okay. The last one, right? 2 ordered pairs with a slope of 6. Just remember that as a fraction. 6 is 6/1. Hint, hint. Okay. But there you go. So finish the page for your homework here. You've got a couple graphs, a couple equations, then go over to the quiz. It'll probably be 4 questions. We'll make it 4 questions. And at least 3 of them will be directly from your homework. So you're not doing things twice. But then I can kind of gauge and see how we're doing, and then I'll plan tomorrow's lesson. All right, enough yapping. You can get to work. The quiz is posted whenever you're ready for it. That, folks, is How You Math. Don't forget to like and subscribe, and have a great day. So long, fellers.